Hi everyone, this is an Arduino microcontroller. Micro obviously because it's quite small, a controller because it can control things. So essentially how this works, we'll kind of cut right to the chase. An individual would write out code on their computer. That might be code to control light bulbs, control motors, might be hooked up to sensors for input, touch sensors, temperature sensors, things like that. An individual would code on the computer. They would attach their microcontroller, their Arduino, to the computer like this through a USB port, and then they would upload the code onto the microcontroller, and then that code would just run continuously. So a microcontroller only holds one program on it, and it would be a program that might control, like I said, lights, might control motors, buttons, have input for tilt switches or for remote controls. But essentially the microcontroller just holds one program. And again, that program is written on a computer, uploaded to the microcontroller device, and it actually runs whatever the code tells it to run. Now, this is an actual Arduino. Arduino is a name brand. You can see it right there, Arduino. The developers of Arduino, they made all of the design specifications open source, meaning anyone was allowed to see how they designed this. And because of that, we have a lot of, we'll call them clones, but not really knockoffs. You know, they're legal. And because all the specifications for creating these was developed by the Arduino company, the organization, and then put as open source, we have other products that might sell themselves as Arduino clones. So this is an example. This is an SM Raza Uno R3, but you can see it's designed almost exactly like the Arduino. So if you happen to be shopping around for these for classrooms and things, you may find the actual Arduino, or you might find some of these clones. There's different quality for all of these, so always read the reviews, but there are some really great ones that actually aren't the Arduino product, but are some of these clones. But they work exactly the same like the Arduino. It also was a really interesting conversation in class to discuss with students, to discuss open source, just the idea of it, the idea of sharing knowledge with everybody else, the idea of the potential for more innovation if companies do like the Arduino company did, where they share their knowledge, they share the diagrams, they share how to build one of these, so other companies can build them and they can get them out to even more people. So it's kind of an interesting discussion. So I'm going to work with this one today. This is the Arduino clone, and I'm going to show you the way this presentation will work is I'll show you a quick kind of physical hookup, and then we'll spend the rest of the time doing it virtually using a simulator. So Tinkercad has a wonderful simulator for Arduino where we can show you how we'd write the code. Students can do this remotely. Students sometimes in our engineering classroom, students use the simulator for prototyping. And then when they finally got it all working, they can build their actual final product. So when we use Arduinos or microcontrollers, quite a lot of time for making with microcontrollers, we'll use breadboards. This is a breadboard right here. It's named after the original breadboards. A long time ago, before all these devices became so small, people would actually create circuits on an actual breadboard. So they would screw down light bulbs, screw down wires onto breadboards or big blocks of wood that look like kind of like a chopping board, like a breadboard. And so the name has stuck. This breadboard has wires underneath it that you can't see. So for example, there are wires that connect these 5 holes right here. They're actually all connected underneath, meaning the electrical circuit is complete underneath. The rails here, there's power that's powered to all of these rails, and it would go all the way down. So I'll show you when we get online. I could show you a few of the different resources that are available to understand how the breadboard works. But essentially what a breadboard allows us to do is to plug and unplug things very quickly. So rather than taping them together, taping all the components together, a breadboard allows us to prototype very, very quickly. We can plug things in, unplug things, and we can do that very quickly. All I have into this breadboard right now are 2 wires. One would be connected to a power source, the other would be connected to ground. We also have an LED or a light bulb, and then we have a resistor because we don't want too much power going to this LED, otherwise we'll pop this LED. So we're jumping right into it, and then we're going to work backwards and see how we would build this kind of in a backwards fashion. And then at the end of this presentation, you'll be able to do this kind of as a simulation using Tinkercad, and then eventually you'll be able to do this with the real thing in a classroom. One thing of note, you do have to pay attention to LEDs. There's one leg longer than the other. So you can kind of see there that one leg is longer than the other. And so that's because one's for positive and one's for negative in terms of the electrical circuit. And that's very important. So sometimes if students are working with this and they've got it backwards, that's one of the reasons the LED might not be working. So this is just a simple hookup for an LED, small little light bulb. And there is code on this Arduino clone here that basically just flashes. It sends power to pin number 13. You can see it there for 1 second, and then it turns off. Power, off, power, off. And so essentially what we've coded and what I've already uploaded to this device is just code to make this LED flash. So the power comes out of pin 13, goes through the LED, the resistor, back to ground. Now this isn't powered right now, but I will take my cord that's plugged into my computer, and as soon as I plug it in, this will have power and it will start running this code on a loop, and we should see our LED flash. And it does not. Remember we talked about the leg, the length of the leg on the LED. So if we've got this inserted backwards, which we do, then we won't be getting the power out. If I reverse the leg, beautiful. We've got a flashing LED. Now, not super fancy. I mean, it's one LED flashing. I get excited about this and the students get excited about this because this opens up so many potential projects. It opens up the potential, which is what we're going to look at, the potential for creating traffic light system, which gets you thinking a lot about the order, sequential instructions for turning, say, a green light on, a yellow light on. We've also worked with students where they'll wire a whole bunch of LEDs on their breadboard, and we'll tune it to music. So they'll find their favorite song and they'll have to make kind of like a light show with music. Other students have printed out one of their favorite photographs and they will put LEDs in the background, and then they'll have these LEDs shining through to music so that it's almost like this animated art piece with LEDs flashing in the background. This is a sample of the different LEDs you can get, all of course different colors. I'll show you a few other components of kits that you might find. These are some examples of the different buttons that you might have. These are tilt switches. So there's a little metal ball in these, and when you tilt it, it completes the circuit, turning a light on or turning a light off. And I'll show you all the different potential peripherals. You see it comes in a kit that looks a little bit like this. A little overwhelming, but the potential kind of for projects is endless. This is the famous little servo motor. So with a little servo motor, you could do all sorts of great things. This is an 8x8 LED grid, kind of like a grid LED matrix. You see the number 8 that you could flash all sorts of different numbers for, make scoreboards, make countdowns. There's sensors in here for remote, and then there's a little remote control. So students have created projects like that. There are even pin pads. A pin pad like this. So someone made a lockbox with a safe. You would punch the code in, the microcontroller would understand the code, and then even ultrasonic sensors, so to put on a robot. So the opportunities, of course, are endless. With the Arduino and with the microcontroller, I always start with students working with just an LED because it gets the major concepts together, and then they might progress to something like this. So there's a little Arduino clone right in here, and that's basically the microcontroller for this entire robot with the ultrasonic sensor on the front. And when you're uploading code, you would do just like we did. Take the wire, plug it into the Arduino, and that's where you would upload all the code to get the motor working. So that's a very quick introduction. We're going to jump now to the online simulator in Tinkercad. So if you're overwhelmed, and we kind of went through those instructions very, very quickly, do not panic. The point was to show sort of the end case, and now we're going to work backwards to simulate building one of these, and we're going to code it as well. And then after that, you will be rolling. All right, so we are now taking things out of, I suppose, the physical world. We're going online for a simulation. So we're going online to use Tinkercad, Autodesk's Tinkercad, to make these simulations or a prototype of what we're designing. If you remember, we had built this, the Arduino clone hooked up to the breadboard with an LED. There was code on here that we uploaded. I know you didn't see those steps, but we uploaded the code to make this LED flash for 1 second, flash on, flash off, flash on, flash off. And so now we're going to code that in Tinkercad in the simulation. Tinkercad is wonderful. If you can't get your hands on the Arduinos right away, then you can use Tinkercad. The students can design and prototype all their projects. It's also great. Sometimes in class we might pop a few LEDs, might damage some equipment in our prototyping. So the simulation using Tinkercad allows you, you can pop LEDs all you want because it's just simulated, so you're not spending any money on those things. It's also great for students to go home and prototype at home and then they might come in with a completed project in Tinkercad, and then we actually hook it up physically in class. So it saves a lot of time and very useful. So this is Tinkercad. They also do 3D design and things like that. We are going to use the circuit capability. So I've logged in here. And I'll go quite quickly because I know this is kind of for asynchronous learning, so you can pause it, you can get to the different places. So you would go to Tinkercad online, tinkercad.com. You would set up an account, log in, and then instead of 3D designs, which is the default, we're going to go to circuits. So you click on circuits, and then you create a new circuit. And we are presented with this screen. We have all of the different components down here on the left. You notice there's our Arduino. We can also do microbit. There are motors, like the servo motor. There are resistors, photoresistors, ultrasonic sensors, all sorts of fun stuff. We're going to start by just dragging out our Arduino. There it is. And we're going to start, second thing we're going to do is drag out our breadboard. And there it is. So we are basically designing this in the simulation, kind of in Tinkercad, and then we'll be able to add code to it and then get it all working. So if you remember, in our physical build here, we had 2 wires, a resistor, and an LED attached to the breadboard. So I'll set up our first wire coming out of pin 13, and I click, and then I'm going to change the color just so it's consistent with the one that we built. I'm going to change that black. So you can see the wire coming out of pin 13 into this row here. I'm going to just knock it down into that row there on the breadboard. I'm going to grab an LED, and I will put it right there. Then I'm going to grab a resistor, and I just need to spin the resistor. So up here on the left, I can spin the resistor. Whoops, dragging everything there. And I will attach it from where the LED plugs in, so from this same row, through the resistor. And then I'm going to take a wire back to ground, and I'm going to make that yellow so it's consistent with our build. So what's happening here? We'll use this example for the travel of electricity. There's sometimes some discussions on whether the electrical current, if you think of it as coming out of ground or coming out of pin 13. For the sake of this discussion, we'll say that it's coming out of 13, going through the LED, through the resistor, and back to ground in the Arduino. And so that's the basic setup. And again, I know that went very quickly, but you're essentially bringing out all of the components down here on the left, dragging them out into your build. And then what we're going to do is we're going to click right here where it says code. And we're going to click code. This is the block-based coding. Very similar, looks like Scratch that some of you may have done working with students to code in kind of a block-based environment. We are going to use text-based environment. So instead of blocks, we're going to go text. I'm going to click continue. This is some code I had from previously, so I'm just going to get rid of that for just a second. So this is our blank area where we can type all of our code. And this is what it would look like when we use the Arduino code. So when you're programming the actual physical component, the Arduino, you would download the Arduino software, and the code is exactly the same. So that's the fun thing. We can work with the code in here. When we're ready to build the actual physical device, we would just copy this code into the Arduino software. So we'll go real slow here, and I'll show us each of the components of the code. I have the code over here. So the first thing we're going to do is to set up a variable for our red pin. So we know that it goes into pin 13. It's right there. So we're going to set up this variable called LED red, and it's going to equal to 13. The second component of the code is a quick setup, and this is in all Arduino code. So you would have void setup, and we're basically setting up the Arduino to know that LED red, or 13, is for output. So the pin number 13 is going to be for output. We're actually going to send information or data or electrical impulses out from 13, as opposed to receiving input in a sensor or something like that, like a temperature sensor. So we've set up now that number 13 is going to be for output. We then start our loop. So there's the code to start our loop. As we said, the microcontroller will just loop code continuously. So that's our code for the loop. And then the final 2 pieces of code, I'm just going to paste them in and then explain them. We are going to digital write to pin number 13 high. We're going to delay for 1 second, or 1,000 milliseconds. And then we're going to digital write to pin 13 low. And we're going to wait for a second. So essentially it's electricity for a second, high, and then low for a second, high for a second, low for a second, eye for a second. I think you get the idea. And so that will create our LED, the flashing part of the LED. So it'll be like electricity, no electricity, electricity, no electricity. And that's essentially what we've programmed here. So we've set up pin 13, we've set it up for output, we've said high power for 1 second, low power for 1 second, high power for 1 second, low power for 1 second. And then all that's left to do is to run the simulation, so to start the simulation. Now there's still the question of if our LED is plugged in the right way. I've left that up for you to kind of consider. So when we start the simulation, it's running right now, no flashing LED. So I'll stop the simulation, take the LED, I'm going to spin it. There we go. And now it's the other way. I'm just going to move this resistor down a step too so we can see it. Now I'll start the simulation again. Beautiful. We have our flashing red LED. Again, I am well aware that we've gone quite quickly, but the point was to really get a project going right away, and my hope is that you can pause it as you get to each of the components. Again, essentially we just built this, our flashing LED. We were able to simulate it. So what's next? So what's a nice next step? Well, if we've got one flashing LED, there's no reason we can't add some more. So I'm going to stop the simulation here. So we are going to continue by adding another LED. The kits that you buy, the kits that you purchase come with a few LEDs. You can also purchase these on Amazon like in packs of like 300. And it gets really exciting. I like to work with LEDs right off the bat because the startup is pretty simple. There's not kind of all different code that you would send to an LED. It's usually either on or off, so it keeps it nice and simple. But you can also get quite creative. So the restraints of an LED kind of force someone to be creative. So it forces the students to think, okay, maybe I could set this to music, just flashing lights on and off. I could even make kind of like a going back and forth type of pattern, like a runway. We've even had students bring in their old Hot Wheels cars, and they've 3D printed a little traffic light, and they actually set up traffic lights with different LEDs. And so they had an actual intersection with two-way traffic, like a four-way intersection, and the cars were stopped going this way, cars were going on that way, and green lights, red lights. It was all lots of fun. So I really like working with LEDs right off the bat. We are going to jump back to where we can actually have our different components. So right now we're in the window where we can see our code, and as you remember, our light is flashing on and off. So if I just click the code where it's highlighted in blue, we will get back to our different components. And I'm going to bring out a second LED. I'm going to change the color of this. Let's go green. So I'm going to have that set up over here. This is our green light. Then of course I need some wires. We're going to run a wire out of pin 12. So I run my wire out of pin 12. I'm going to change the color of this wire to be consistent with the other one, so I'm going to make it black. Bring my resistor out up here, top left. I'm going to rotate the resistor, same as the other one. Now for our ground wire, I'd like to run a wire back to the Arduino to ground, but that pin is already being used. So this is a big step. So what we're going to do, instead of using the ground, have everything going into the same pin, we don't want to do that. We'll damage the Arduino. So I'm going to take this, I'm going to take this yellow wire that was our ground, and I'm going to delete it. And I'm going to run a ground wire just to our bottom rail here. So the bottom rail goes up and down the base of this breadboard. And so that means that this entire thing is now ground. So that means we can run this wire from here to here. And to stay consistent, I'm going to make that yellow. And I can even run a ground wire from here to here. And again, to make it consistent, I'm going to make that yellow too. So if you follow the path of electricity, let's say it comes out of 13 through the LED, through the resistor, through the yellow wire back to ground, which is all this whole entire line, this entire rail is ground, and then back to the Arduino to ground. If it's out of 12, it comes up the wire through the green LED, through the resistor, back through the yellow wire to the same ground, and then back again. So we're using this pin for multiple grounds, which is good practice, and it works great. The only thing, I'm just going to rotate my green LED so we make sure that the legs are going the right way. The legs are at the positive end, and the negative end, the shorter leg, goes to ground. And I'm just going to move that up a little bit. When we jump to our code, as you remember, this was flashing our red LED. So if I run this simulation, I haven't broken anything. So I make sure I haven't broken anything. So the red LED is still flashing. Now I need code for my other one. So I'm going to call this green LED. It comes out of pin 12, semicolon. I make sure that I do the same thing. Actually, I should be consistent here. Let's call this LED green, right, to be consistent. In case someone else uses our code one day, we want to make sure we're nice and consistent. This is also for output. And then in our code down here, what we're going to do is we're just going to try something. We won't do traffic lights, but we'll just turn the red light on and the red light off. And then I'm going to copy this code, paste it down here. We're going to turn the green light on. So LED green high, LED green low, and then it'll loop back and turn the red back on. So it should go, hopefully, fingers crossed, red on for a second, red off, green on for a second, green off, and then loop back again. Red, green, red, green. Let's see how this goes. Here it is. A little nervous, gotta be honest. Let's start our simulation. Red. Yes. Success. So red is on, green is on. Red is on, green is on. Perfect. I'm going to stop the simulation, and this is our delay right here. So we have this for 10,000, sorry, 1,000 milliseconds or 1 second. I'm going to change this just to, we'll have the red light go on for 2 seconds, and then we'll have the green light go on for 3 seconds. So it should be 2 seconds of red, 1 second everything off, 3 seconds of green, 1 second everything off. Let's see if this works. Green for 3 seconds, red for 2 seconds, green for 3 seconds. And the reason I call attention to that is because that's what students will have to start doing when they consider their traffic lights. The other thing students will have to consider is, how does a traffic light work? Like, what is the order of the lights? I've seen a lot of students program it to go red, yellow, green. Whereas a traffic light doesn't really do that, right? It goes green, then the yellow, then the red, and then when it's time to turn green again, it jumps right back to green. And so there's a lot of, we'll say, computational thinking. There's a lot of algorithm design. There's a lot of thinking that goes on with very, very simple components like an LED, which is why I like to use it as a one of the big primary activities. So again, we've comboed this. We've done quite a few things here in a short period of time. We've worked with the physical device, and then we've kind of gone backwards to where we would start the prototyping with the code and the simulation, and to see if we can get it working in the simulation and the prototype design stage in Tinkercad. And then now what we'd normally do is start with the simulation. Once it's working, we could then build this very, very easily with the physical components once students get their hands on the physical components. So it's a really great practice because it shows students the importance of prototyping right before you jump into the actual physical components, which is really nice. I will show you a couple different resources if you are interested. Arduino tutorials. Perhaps the precedent set by the Arduino Foundation when they created the Arduino and let it go open source. There's a lot of sharing online. People are always sharing code. So if you type in, like just in Google, an Arduino startup activity or Arduino LED, you'll find all sorts of instructions. You can also download the actual Arduino software. So just as a reminder, the Arduino, when you're programming the Arduino or the Arduino clones, you would download the Arduino software, and then that's how you would upload it to the actual device. You can go, if you'd like, techthings.ca. So this is just a website where I put a few of my resources. Techthings.ca/learn. So it's up here, techthings.ca/learn. And there's a site there, Arduino Microcontrollers, Introduction to the Arduino, flashing an LED, a 7-segment LED, that's like our number 8, where you can have different numbers appear by lighting up different components of the LED. There's buttons there, tilt switches, photoresistors, so that might be a good place to start. Some of the other projects I just wanted to show you where students might end up going with this. This was a project done a few years ago. Potentiometer is turned on to set the time, and basically it was an alarm clock. This student's brother had a 3D printer. So she designed a box for this alarm clock. She actually had it 3D printed at her brother's house, and then she brought it in and she actually designed this with the Arduino. It was a full working alarm clock. This student connected an Arduino clone to sensors, some monitors that basically sense the muscular activity in your arm.
Now he wanted to build kind of this big elaborate project with this. It turns out in the amount of time we had, we were just really happy to actually get it registering the values on the screen. So as he flexed his muscle, it would actually change the values on the screen, which was pretty exciting because at that point, years later, students took that initial code and they turned it into being able to control actual physical components. So by flexing your muscle, you would see motors turn on the table, which was very exciting. And this one here, just a simple dice. So this is 5 or 6 LEDs. And when you press the button, it just randomizes a number between 1 and 6. And then it shows that the Arduino code then shows that by lighting up specific LEDs. So generating a random number, you're thinking maybe perhaps is tricky, but the idea of wiring 6 LEDs, we've just done the 2. So you would just repeat that process and repeat the code. So it's exciting because it opens up all of these activities to students, including the LED light show with music. It's just the initial startup might take a little bit, but then once students see the LEDs flashing, it's just magic. And creativity takes over and you see all sorts of different ideas and all sorts of different projects. So that's a kind of a quick introduction to making with the microcontrollers with the Arduino. We looked at the physical components. We also looked at great simulation software using Tinkercad. And now a big challenge that you may want to try out, that I'd suggest, is to try to get the 3 traffic light system working. So try to jump back to Tinkercad, add a yellow light, see if you can hook that up to maybe pin 11, or maybe you want to move the green light to pin 11, and you want your yellow light in pin 12 perhaps, and then see if you can code it to make those instructions work so that you actually have kind of a functioning traffic light. The secondary kind of challenge I'd propose is to add all sorts of fun lights in here and see if you can get something working with your favorite song. So something that you would put either in front of an image or just a nice little funky light show that's responding, that seems as though it's responding to the music. So you work with your delays, you work with kind of suddenly when something drops in the song, you have this really exciting lights flickering. So there's all sorts of potential for creativity. So enjoy. Thank you.